is away, and if any change in the measurement, the patient can be addressed at the spot. Can we? Madam, at least 18-19 months.
ఇక్కడ మామూలుగా చేస్తున్నాను బ్లడ్ ప్రెషర్ అదే టైట్గా ఉన్నప్పుడు ఇంకా ప్రెషర్కి కొంచెం కౌంట్ వస్తూ ఉంటుంది అదొక ప్రెషర్.
హలో వీడియోస్ ఇక్కడ ఇది వెబ్సైట్ మొత్తం రికార్డ్ అవుతుంది.
Project is that we are designing the rectangular microstrip patch array antenna. Actually, Vbit is nothing but it's an extension of Wi-Fi. Wi-Fi covers only up to certain range, as you already know, up to 100 meters. That's it. Means we could cover this distance. We could increase the distance. Nothing but in rural areas we could cover up to 10 kilometers, and compared to urban areas we could cover only up to 4 kilometers because of the reflections with the buildings and other all elements. So, coming to the designing, we are designing this microstrip patch array antenna. First, going to the single antenna. This is a single antenna. This is a microstrip patch antenna. Here is a radiating element, which is nothing but the patch, and this is the substrate whose dielectric constant will be 4.3. Dielectric constant, we could change the dielectric constant, but we are considering the available dielectric constant as 4.3. Actually, the dielectric constant range should be between 2 and 12, but we are considering 4.3. You could also choose other constants also, like 4.6 and all. But when we consider low dielectric constant only, it would be providing more coverage here. And coming to this, brown indicates the substrate and yellow indicates the patch, and beneath that is the ground plane. Port is indicated by the red color, to the means of which we are exciting the antenna. And the material used for the ground plane and the patch are the same. Patch is nothing but the radiating element. So, we are using the 50 ohms feed line for the excitation purpose. To match this feed line to the patch, we are designing the matching transformer, that is lambda by 4 transformer, according to which impedance is to be calculated. This is 50 ohms impedance, and to match this 50 ohms to this patch, we have to calculate the edge impedance of this patch. For that purpose, we are using the formula under root of 50 into 100, which is approximately 70.1. So we are designing
Time by the doctor. So we have improved a technique, the Zigbee-based physiological parameters monitoring system. Any changes in the health status of the patient can be monitored by the doctor on the spot. So we are using and we have used the ARM processor for this technique, sir. For the wireless transmission, we have used a Zigbee module, sir. Instead of that, we can use Bluetooth or Wi-Fi. But why we have used Zigbee is that it is a low power consumption supply protocol, sir.
And we'll be monitoring from each minute. Already in ARM processor it will be inbuilt timers for every minute, and they will be counting for every minute. This will be heartbeat sensor, sir. If you want, you can check. Every minute it will be displaying, sir, and it will be sent to the receiver. It will be displayed the doctor, sir. They will be monitoring for every minute. It is not possible to go in every time and near one patient it will be monitoring. So it is each minute it will be. Yes, sir. Yes, sir. 70s.
How differently you will just already existing like.
And you'll be observing all the meters, all the parameters, sorry. And it will be a time waste and you'll be consuming a lot of time lost.
More physical parameters.
And we can increase the number of sensors also. By increasing the number of sensors, you'll be measuring more parameters.
So what made you to choose this kind of project?
Actually, we have done a mini project based on ARM7, so we want to extend some more project, some more development comparing to the mini project. So we selected these projects to do on ARM7.
Facility is there in all hospitals?
No, sir, it is not existing in all hospitals because it is costly, and in small hospitals they will be not preferring it.
How much it costed you?
12,000 around. Yes, sir.
Spent from your pockets.
Yes, sir. My dad is.
Matching these two, we have to design a matching transformer, sir.
Yes,
Using we have to calculate firstly the edge impedance
Yes,
of the patch. Then we have to match this to the transformer.
Total kit 12,000. 12,000.
When we increase the number of elements, we'll be getting
It's in
Otherwise, how much?
increase the number of sensors and the cost will be increasing. 3 more sensors. Sure.
That will be the end of
Thank you, sir.
and the fabricated results, you can observe in vector It is to design the rectangular microstrip antenna for WiMAX applications, sir. WiMAX is that it's an extension of Wi-Fi, sir. Using Wi-Fi, we could cover only up to 100 meters, sir. But using WiMAX, we could cover more distance, sir. It's an extension of Wi-Fi. We could, in the rural areas, we could cover 10 kilometers, sir. While urban areas, we could cover 4 kilometers, sir. Due to the reflections on the buildings and other objects, sir. Using Wi-Fi, as you could observe, sir, this orange region indicates a coverage region, sir. And using WiMAX, we could cover entire regions. And for this purpose, we are designing the microstrip array antenna, sir. This is single antenna, sir. Actually, we have chosen this antenna because of its low size, low cost, and it's versatile and it's conformable, sir. Nowadays, for industry and commercial purposes also, we are using this antenna, sir, in mobiles. So, microstrip antenna consists of the patch on one side, sir, and ground plane on the other side, sir. And for both purposes, we are using copper as a material, sir. And brown indicates the substrate, sir, FR4. Is the flame retardant substrate, sir. Actually, we have to choose a substrate with low dielectric constant, sir. RT Duro at 570 is suitable, sir. But nowadays in market, the FR4 is available, sir, readily. That's why we have chosen this, sir. And its value is 4.3, sir. It's a constant. And red indicates the port, sir, to the means of which we have to feed this antenna, sir.
All the guides are requested to be present at their respective stalls.
We're using 50 ohms feed line.
When visitors,
Actually, we are
distinguished guests are visiting, I request all guides to be present, to be available at the respective stalls.
Higher power handling capacity is 73 ohms. And the root of 37 and 73 is 50 ohms, sir, approximately. So we have chosen 50 ohms feed line, sir. To match this feed line to the patch, we have to design the matching transformer, sir. That's why we have choose this matching transformer, sir. And to design this, we have to first calculate the edge impedance of the patch, sir. This is we have designed using 70 ohms, sir. This impedance is 70 ohms. And with single antenna, we'll be getting low gain and directivity, sir. As you could observe here in this diagram. This is a radiation pattern, sir, of the single antenna. When we go on increasing the number of elements, nothing but radiating elements, then we'll be getting more gain and more directivity, sir. That's the aim of our project. So this is a linear configuration we have arranged, sir. Array configuration. Linear in the here. We have to use this matching transformer whose impedance is 70 ohms, sir. And actually we are using this corporate feeding network because equal amount of power is transmitted to all the patches, sir. And we could increasing when we change the frequency, that is when we increase the frequency to 2.5 instead of 2.5, then also we'll be getting more better results, sir. It's an open-end frequency, so we are choosing this, sir. And this is the VSWR, sir, 1.06.
How far is the
More coverage.
and usability? That is flexibility of code. Auto limit tell you
And by 1/16, then we can use it, sir. We can implement it.
where do you say, suppose you don't have finance campus,
Yes.
implement that. Like that application.
We done, sir.
What an interesting part in signal mechanism is we have some everything that we can say. Hospital. We can have it in mind, we can execute it.
Both are same? Different.
Our project is design of CPU microcontrollers. Our block consists of the total of 9 modules in the CPU, sir. Whatever the instruction I am getting from the ROM is taken into the instruction register. In the instruction register, it holds the instruction as long as it is being executed in the whole CPU cycle. So from there it is given to the instruction decoder to notify whether it is a single cycle or 2 cycle. Single cycle means it gets operated in 2 clock cycles, you can say. 2 clock cycles. So after it's determining whether it is 1 or 2, then it goes to the final state machine. The state machine tells whether it have to operate it in state 1 or state 2. State 1 is completely in 1 clock cycle and state 2 means for the both clock 1 and single cycle and 2 instruction cycles. The control cycle, it gives all the control signals to be done in the CPU. Control units, like control signals such as what are the flags to be generated, when the prefetch should be high so as it can get the next instruction to be loaded into the instruction register. So all the control signals are given in the control unit. My operands are AIN and BIN, then I'm doing the logical operations such as AND or XOR whatever. Then my ALU output is taken back into the control so that it can generate the controls. Suppose that I've got an interrupt in between my operation, then my address is stored into the stack. My address of next instruction is stored onto the stack. So after the execution of the interrupt, then the return is given in the same stack. So after the return, it gets back into my original program. All the operation is done in the stack. Yeah. And the RAM stores the program data. It also is given back into the input to the control unit. So for the whole control unit, for the whole CPU, we are getting the instruction, then getting the logical operation to be done. What are the control signals? I am getting the output. That's it. And 10 nanoseconds clock is generated, and it can be operated in 100 megahertz and also above. Can I? Thank you.
So you might have known about the World Trade Center crash that happened in 9/11, sir. What exactly happened is, sir, terrorists have sent some information. It can't be done through mails, no, sir. Mails through a phone call. So what have they done is they've sent the image, they've sent the text that they have to crash the World Trade Center through embedding that text into an image, sir. That is called steganography, sir. Embedding something under something is steganography, sir. So what exactly happened in World Trade Center crashes? They've sent it through an image, sir. The text is been written under an image and it has been sent, sir. That is image technology, sir. Our product is audio technology, sir. Embedding information in audio signals, sir. So we are embedding ciphertext, sir. So if someone, what exactly happens is we are converting the text into ciphertext, sir. It's an unreadable format, sir. So once it's converted to unreadable format, the third person can't know what is my text, sir. Only the sender and the receiver will be able to know what is the text exactly. I'll be inserting a key, sir. So if the third person knows what is the key, he'll be able to retrieve the text, sir. Else it can't be hacked, sir. So I embed this ciphertext in an audio signal, sir. So the technique I use is LSB algorithm, sir. So what happens exactly is the main text that I want to send is being converted into ASCII format, sir. So the ASCII format goes like this, and this is the text I want to embed into the audio file, sir. So my technique is LSB algorithm, least significant bit algorithm. So I take the 0, I put it in this place, sir. This one here, this 0 here. So scattered into the audio signal, sir, and the audio signal is being sent. So what exactly happens is, you get to hear the audio, sir. A human ear can't perceive this audio, sir. It gets embedded completely, and I send it to the receiver. The receiver receives the information, he extracts the image, sir. This is what is my project about embedding ciphertext in an audio signal using technology. And this technique has been used in 9x11, sir. It has been done in image technology, sir. So it took around 6 to 7 years for them to know that it has been done through a process called technology. Then Obama has done the same in audio technology, sir. They've used Pakistan has used image technology, sir. Obama has used audio technology, sir. The future of this is in video, sir. And the result goes like this, sir. This is the text I want to write here. And the text I write it in here, sir. And I select an audio file, sir. Once I select the audio file, any of the wave files, sir. So I select the wave file and I click embed text, sir. Click to hide text. Once I click this, the text converts into ciphertext and it gets hidden, sir. The key is already inbuilt, sir. I give it as 3, 4, 100, anything. It's my wish. So once the text gets hidden and a new wave file gets created, sir. So the new wave file is this, sir. Now the receiver has to recover the text. So he clicks the option called recover text. Recover text and he'll select the audio file, sir, through the newly generated audio file. This is the audio file, sir. Once he generates the audio file, he'll get back the text, sir. We've just given it as hello world. There, it will be their own message. And the applications nowadays, it's been used in JNTU for sending the question papers to all the colleges, sir. In JNTU, SRM and Vbit and all, they embed the question paper under an image also, and it's been sent, and all the colleges extract the image, sir. That is how question papers are generated in all the colleges. Yes, sir. They pass it will be sent to the college, and with that they'll extract the question papers.
So what we see with our eyes is only for a particular frequency. Below that, which we can't see, sir. So for that, we use this Eulerian video magnification method, sir.